this spoon just to show you how to take a really quick high quality render. First, ensure that the Render Tools tab is enabled, and then let's activate PhotoView 360. Next, we are going to want to apply material. This option can be found on the right hand side. Just choose whatever material suits your design or object. And next we will be choosing a scene. Just choose a basic scene that will provide a good backdrop for the object. Next we will add a camera. This will create a new viewport on the right hand side. And the camera can be positioned by simply moving around in this new viewport the same way you would in the model space. Once you have found the desired position, just press OK. Next we will add lighting. First I'm just going to show the camera to use as a reference, and then I'm going to delete the existing lights. We will use a configuration called 3-point lighting. This consists of a key light, a fill light, and a backlight. The key light is meant to be twice as luminous as the back and fill lights. For my key light, I am going to use a spotlight. I will position this light in front of the object and to the left of the camera. This is my main source of direct light. When the light is in the correct position, simply press OK. Next we will add a directional light. This is our fill light. This will also be in front of the object, but this time to the right of the camera. Lastly, we will add one more directional light and place it behind the object. This is our backlight. This will remove any shadows imposed by the first two lights. Ensure all lights are active in PhotoView 360. And from the viewport pane, select the camera view. After this, select Final Render and wait a minute for your render to process.
Start off by selecting the line tool and join the simple straight sections first. The more complex curved lines are drawn using the spline tool. The spline tool generates what is essentially the SolidWorks version of a Bezier curve. Once the spline tool is active, click on the starting and ending locations for the intended curve. Each endpoint of this new line will have the ability to modify the curve orientation. This is accomplished by clicking on the small arrows attached to the curve and dragging, extending, or retracting them until the curve is correct. Aligning the curve appropriately can be a little tricky since you have to make sure all three dimensions are in the appropriate orientation. Rotating the camera to check all viewpoints is suggested, as what appears to be correct may very well just be a matter of poor perspective. With some diligence, three-dimensional orientation becomes much simpler over time. Repeat the simple lines and curves until the desired sketch is complete. Once you are happy with the new sketch, go to the Surface tab and click Filled Surface. This will create a solid which is bounded by the sketch perimeter. If it is not quite what was intended, it's a simple matter of editing the sketch until the desired surface is created. Once the grueling task of 3D sketching the model is complete, it can be transformed using weldments. Clicking on the Weldment tab and then the Structural Member button brings you to a list of parameters that need to be set up. In this case, 0.5-inch Schedule 40 piping was used. Once the parameters are set up for the weldment, click New Group. Apparently, a group is a set of weldments that are connected end to end. Starting with the longest group, select the sketch lines and you can begin to see the preview of the weldments. When there are no more line sections appropriate for that group, click New Group. Again, you'll be able to start clicking on more line segments appropriate for that grouping. This process is repeated until all the desired weldments for a specific weldment type and size are created. As the group list grows, the computer's implementation of the new weldments becomes much slower, so it could be advised to perhaps limit a specific weldment feature to the capabilities of your machine. Once all the lines intended for that specific size of weldment are selected, press the check mark and view the gloriously transformed model. Oftentimes there will be cases where the weldment seems to be slightly distorted, but that can be fixed later on. In the case of this model, we are using an additional larger size weldment. Again, clicking on the weldment and structural member buttons, and then adjusting the Schedule 40 sizing to be 1.5 inches, we can complete the model with the rest of the weldments. Now it is possible to fix all the wonky weldment connections. Right-clicking on the smaller weldment feature in the feature tree and editing it will show purple nodes. These nodes can be clicked on and the weldment connection priorities can be modified by changing the values shown from 1 to 3. Further tidying up can be accomplished using the Trim Extend feature found in the Weldment tab. Once the feature is selected, selecting a body to be trimmed and then a body to trim will result in a cleaner and hopefully more realistic model. It is very likely that there will be multiple instances of strange connectivity and sections of weldment that need correction, so diligence in checking the entirety of the model is suggested.